All right, so we are going to go through those clicker questions today. So we're going to start with number 11. So number 11 says if I drop something from a certain height h, it takes a time t to reach the ground. What happens if I go to a height of 3h? Okay, so what we're going to do to solve this one is we are going to essentially get an equation that relates h and t. So I don't know v, so I'll pick an equation that doesn't have v. So we have equation number 2, so y final minus or equals y initial plus v naught t plus 1/2 at squared. So we cross out anything that is 0. And so now I have a relationship between those two variables when I plug them in. So I'm going to move this 1/2 at squared over to the other side. So I have h, v naught, or y naught, is equal to 1/2 times g. The negative I got when I moved it over cancels out with this negative, times t, which is this t, squared. Now, what happens if I triple the height? What happens to time? So when we do algebra, if I multiply this side by 2 to get rid of the 1/2, I'd also have to multiply this side by 2. So the same thing holds true here. If I multiply this side by 3, in other words, make this 3 times the height, I got to figure out what I'm going to need to multiply t by so that it's the same thing on both sides. So this quantity squared has to equal 3. So I have to multiply it by the square root of 3. So that correct answer for number 11 is B. Number 12, if you toss a ball up, talk about the point at the top. Well, at the point at the top, when it reaches a maximum height, the velocity is 0. Gravity is always there, so gravity is acting down. So correct answer is C. The velocity is 0, but the acceleration is negative or downward. All right, number 13 says I drop an object on Earth. How far does it fall in 6 seconds? Okay, so it drops it off a 400-meter cliff. That's fine. You can use that, and then once you find the final position, just take the difference, and you'll get there. The shortcut way to do this is to say it starts at a height of 0. Seems kind of weird, but I'm going to do this. I'm going to say it starts at a height of 0, and I'm going to say down is my positive direction. Okay, that'll save me a step here. So now I can say, all right, y equals y naught plus v naught t plus 1/2 at squared. V naught was 0, y naught was 0. So the distance down it goes is equal to 1/2 times 9.8 times 6 squared. And so you should end up with about 180 meters. So the correct answer there would be D. All right, number 14. Number 14 wants me to find the displacement during the first 2 seconds. All right, displacement, well, it's a velocity versus time graph. I guess I didn't have that on here. So it's a velocity versus time graph. So the displacement is this area. That is my displacement. So one option is you can find the area under the curve. And it's really nice if I know these points, right? So this side has a length of 5, this side has a length of 1. So I can take their average of the bases times the height to get the area of my trapezoid. But I want to show you the other way to do this. And that's based on the idea that displacement is equal to the integral from t1 to t2 of my velocity function dt. Well, in order to get a velocity function, I'm going to first need essentially a function for this graph. Well, a function for this graph, pretty easy to start with acceleration, which is the slope of the graph. So the slope goes up 4 and over 2. So my slope is 2 meters per second squared. The velocity function will be the integral of that, so 2t plus the initial velocity, which I can tell from the graph is 1 meters per second. Now what I need to do is I just need to say what's the displacement from 0 to 2 seconds of 2t plus 1 dt. And I get 6 meters. Now this is really helpful if we don't necessarily know what point we are. Maybe it's like, what's the displacement in the first 1.63 seconds? You'll have to use an integral. So the correct answer for number 14 is C. Number 15. Now it wants me to find the displacement in the first half of a second. Ah, that's where this comes in. So I'm going to have to go from 0 to 0.5 seconds. And in that case, I get 0.75 meters. So the correct answer for number 15 is D. All right, number 16, they show a graph of velocity versus time. That looks maybe something like this. And it asks me which statement is most accurate about the motion. Okay, so my velocity starts out as a big number and it gets smaller and smaller. So my velocity is becoming smaller. So the object is slowing down, so that gets us down to about A and B. Now, what's true about the acceleration? So the rate of the change. So that's what it's asking when it says decreasing rate or increasing rate. It's asking about the acceleration. So my acceleration is my slope. So my slope starts off steep, so I have a big acceleration. And then as I get down, my slope is not as steep, so I have a smaller acceleration. And so the rate at which the velocity is changing is decreasing. So the correct answer there is A. All right, 17, 18, and 19 all are asking basically the same question. Is the acceleration constant? All right, so depending on what you get, velocity or position graphs, all you need to do is take derivatives until you get to acceleration and then determine, is it a constant? So is it a number or is it dependent on t? Okay. So all you have to do is do that for those three. So let's just go through them quick. So x is equal to 4t minus 2t cubed. Then v is equal to 4t squared minus 6, and x is equal to 8 minus 2t squared. I got a little extra to erase here, I guess. So just take the derivative of this one twice, this one once, this one twice to get to our acceleration, see what we get. So x is equal to 4 minus 6t. X, oops, that's dx dt, so we'll just call it v. And then this is a, and so we just get, squared. And then we get minus 12t here. So acceleration is not a constant. So the correct answer for number 17 is no. This one, take the derivative. I only got to do it once, so I get 8t. Again, not a constant acceleration, so the answer to 18 is also no. And this one, we take the derivative twice, so velocity is equal to negative 4t. Acceleration is equal to negative 4. That comes out to be a constant number, so it is. How you can figure this out is if we think about the four equations we have on the sideboard. We have a position equation, x naught plus v naught t plus 1/2 at squared, and a velocity is equal to v naught plus at. These are situations in which the acceleration is a constant. And so you'll notice that the highest order of t for an x is squared. And in a velocity function, the highest order is t to the first. So the fact that I have t cubed here, that automatically tells me that I'm going to have a t to the first here, and it's not going to be constant. Or the fact that I have t squared here means I'm going to have t to the first there. It's not going to be constant. This one has t squared and an x, so that automatically means it's going to be t to the 0. Okay? So that's kind of the quick way to tell if it's a constant or not constant. All right. 20 says the position of an object. Which statement is correct about the object? Okay, so let's write down that function so we can talk about it. So 5 minus 4t plus 2t squared. All right. 5 minus 4t plus 2t squared is my position function, and it looks like it's in terms of meters and seconds. So they ask me about the object is at rest, so when is the velocity 0, essentially. All right, so in order to find when is the velocity 0, I need to find a velocity function. So I have negative 4 plus 4t, and so my velocity is 0. So then my time is, what, 1 second? So it comes to rest at 1 second. So the correct answer is C. All right. Number 21. All right. 21. Oh, okay. 21 gives me the same function again, but this time it wants to know how many times does it pass through x equals 0. So in other words, I'm going to solve this for when is x equals to 0. So one option is I can just use the polynomial 2 and find times. Your other option, and probably the best one in this case, is to just go ahead and graph it. And so you graph it, and you find out that it has a curve that maybe looks something like this on position versus time. It never actually crosses x equals 0. So the correct answer for number 21 is E. 22 gives me a little different equation. It flips some signs on us. All right. And then it wants me to say what the graph looks like. All right. So they give me the function that x is equal to 5 plus 4t minus 2t squared. Okay. So something I like to do on these types of problems, if I got to match an equation with a graph, is I like to think about what these terms are. And this looks a lot like our equation number 2, x equals x naught plus v naught t plus 1/2 at squared. And so half the acceleration is going to be -2, so the acceleration is actually -4. So this tells me about the intercept. This tells me about the initial slope. And this tells me about the concavity. Now, you don't have to think about it in terms of physics, but this would be a very mathematical way to think about it as well, is the t to the first term is slope, t to the second term is concavity. So I'm looking for something that has an intercept that is positive, a slope that is initially positive, and a concavity that is concave down. And so which one of those graphs meets those needs? Graph C meets those needs. All right, 23, the position of an object moving along the x-axis is given by the same function. Okay, so we're using the same function again. Which of the following xt graphs? Okay, so now I just need to get a function for velocity and kind of do the same thing. So my velocity function is going to be the derivative of my position function. So I have 4 minus 4t. Okay. And so it has a positive intercept and a negative slope. So the slope is initially negative, but it's not, there's no concavity, so it's a constant slope. So I get a straight line like this. And so the correct answer for that one would be C as well. And then number 24, we'll do that one on maybe Tuesday or something. All right, go shut it off.